The question says that a person with normal near point 25 centimeter using a compound microscope with objective of focal length 8 millimeter and eyepiece of focal length 2.5 centimeter can bring an object placed at 9 millimeter from the objective in a sharp focus. What is the separation between the two lenses? Calculate the magnifying power of the microscope. So in this question, it is simply asking that what would be the distance between these two lenses such that if object is placed at 9 millimeter or 0.9 centimeter in front of the object, the person with a normal near point of 25 centimeter sees that object clearly. So it is simply asking what would be the length between, what would be the distance between these two lenses such that the person can focus it, or the eyepiece can create an image at v equals to 25 centimeter in front of it. So in order to get the length between these two lenses, we will have to find out the distance between the image created by the objective, that is v naught, and the distance between the image and that eyepiece lens, or we can term it as object length ue. So length will be composed of v0, that is the image distance between the objective lens and the image, and ue, that is the object distance from the eyepiece. That will give us the answer. Now we have to also calculate the magnifying power of the microscope. So in order to find out v0, vo, and ue, we will use the lens equation. So we know that using the lens equation on the objective, we know that 1 by v0 minus 1 by u0 is equals to 1 by focal length of that objective. Now using these values that are given for VO, that is 9 millimeter, we will use it as minus 1 by 0.9. So we will get V0 as 36.5 centimeter. Now what is left is calculation of UE, that is the object distance between the eyepiece and the image formed by the objective. So using the lens formula again on the eyepiece, we know the value of VE, that is the image must form at the least distance of distinct vision, that is 25 centimeter in front of the eyepiece, and we have been given the focal length of the objective, that is 2.5 centimeter, focal length of the eyepiece, that is 2.5 centimeter. So we only need to find UE. So upon calculation, we will get a UE is equals to minus of 25 by 11. Now the length, as we saw earlier, would be composed of V0 plus UE, the magnitude of these two values. So after adding these two values, we will get a distance of 9.47. That is, the length of the microscope would be 9.47 for the clear vision. Thank you. We also need to find the magnification in this case. So magnification is given by VO by UO into D by UE. So we know the value of VO over here. We have calculated it as 36.5, and UO is given, that is 0.9. The distance of the object from the objective. D is known, that is 25 centimeter, and UE we calculated to a value of 25 by 11. So after this formula, using this formula and substituting the values, we will get a result of 88. That is, the magnification of this microscope is 88x. Thank you.